Okay, good afternoon. Thank you all for being here. My name is Mei-Hui Situ, and I'm an assistant civil engineer at Water Resources Agency. And today it's my pleasure to provide a brief presentation about desilting tunnel projects in Taiwan. And this is the agenda for my talk today. First, I will point out the necessity of desilting tunnels. And then I will go over two cases, Zhengwen Reservoir and Shimen Reservoir. In the process, I hope that I will provide some project details that are interesting to you. So why do we need desilting tunnels and what can they do? In a typhoon or flood event, lots of stones and sand from upstream are carried into the reservoir from through the surface runoff, and coarse particles are settled in delta, while fine particles continue moving towards the dam. Due to the higher density of sediments compared to the water, there will be a turbidity current at the reservoir bottom. At the same time, the spillway may be open for flood discharge, but it results in releasing clear water and storing the turbid water. So if we can set up a bottom outlet of sediment deposition, the sediment will be discharged outside directly when the turbidity current arrives. In the upper right corner, you can see the Shimen Reservoir spillway and seal sluicing way. And it can clearly distinguish by the color. So these silting tunnels can not only reduce siltation and save the clear water resources, but also return sand to the river. And in addition, it's no need to be powered. In 2021, the siltation rate of 95 announced reservoir in Taiwan has reached 29.5%. Of the 95 reservoir, 18 of them are extremely important, as shown in the slide. They account for 95% of the capacity. And the two reservoirs I will be talking about is the Zhengwen and Shimen. And the Zhengwen is the largest and the Shimen is the largest in Taiwan. They are significant water resource facilities in southern and northern Taiwan. Both of them are also have been constructed half a century ago, and they experience a relatively severe siltation problem. So to overcome the siltation problem, the focus should be placed on the major flood event. In 2009, the 91.08 million cubic meters of sediments that Typhoon Moraca brought, which is almost the 11% of the Zhengwen's capacity, reduced the Zhengwen's useful life by 20 years. On the other hand, in 2004, the 27.88 million cubic meters of sediments that Typhoon Eri brought reduced the Shimen useful life by 14 years, yes. Besides, Typhoon Eri gave rise to a muddy lake, creating an 18-day water shortage for Taoyuan. So this is the problem, and we did and next I will go into the Zhengwen's project details. Originally, Zhengwen has 3 water discharge ways: the spillway, power tunnel, and permanent river outlet. And to enhance the Zhengwen's sediment sluicing, we converted the Howard Bunker Veil into a jet flow gate. And in 2013, we started the Desilting Tunnel project. The constructions took 4 years and cost about 137 million USD. Its main parts include elephant trunk steel pipe, intact tunnel, vertical shaft and gate chamber, tunnel, plunge port, and outlet. And with 9 different sections, its total length is about 1,270 meters. At the intact area, we faced the issue of constructability because it was close to the dam and in deep water. So it's terms of the reservoir safety and the 60 meters height difference, we were consequently unable to use the leg top and cover dam's mesa to penetrate the end of the tunnel. So we finally used an unique and innovative mesa, which are the elephant trunk steel pipe. And it was not affected by reservoir's water level and could lower the impact level by 20 meters. To ensure the safety and stability, the construction followed the principle of strengthening before excavation. Our first strengthening steps were the pile driving, consolidation grouting, backfill concrete, and slope nailing. This is the photo of construction conditions. After strengthening, we kept construction by excavating of the foundation of steel pipe and balancing the water pressure before moving the rock plug. Then we excavated downward underwater. The steel pipe installation required a total of 120 bolts to connect to the flange. And in order to prevent it from moving and turning, we concrete around it. Finally, we completed the intact construction by adding the bank slope protection. However, the steel pipe was too large and difficult to transport on land, so we set up a temporary factory for assembling it in the reservoir area. And we use water transportation by tugboat. The steel pipe has double layer that creates compartment so it could float and its positioning could be adjusted underwater and by injected varying amounts of water. The other issue was at the outlet, which was the lack of hinterland. We therefore in the river lack of the hinterland. So therefore we evaluated that energy dissipation in the mountain was the best option because it impacts the least. With a large scale of plunge pole, we first used the mushroom head mesa to which can avoid the working high below above the ground and strongly support the roof arch. Then we evaluate and excavated downward while setting up the pre-stretched anchors. And in the outlet, which has an oblique intersection in between the bank slope, we reserve a rock pillar to downside the span of the tunnel. And this is the construction procedure of the rock pillar. and we also call it center wall. The special thing is that it was oppositely locked by rock bolts and three-stretch anchors for strengthening. After the Zhengwen desilting tunnel was completed, it can discharge 1.04 million cubic meters of sediments per year. And this volume equals almost 87,000 gravel trucks. And this slide shows the initial operation benefits. During the heavy rain event in August 2018. For this operation, a total of 0.24 million cubic meters of sediments was released. And this is a short video of the operating. Okay, next, our next case is Shimen Reservoir. Originally, Shimen had 4 water discharge ways. The spillway, power tunnel, permanent PRO, and drainage tunnel. And in 2012, we converted the power tunnel number 2 penstock segment into a sealed sluicing pipe. And recently, we just completed the Amupin desilting tunnel. The Amupin desilting tunnel started in 2017 and cost about 120 million USD. It's a midstream desilting project and contains added intake, tunnel outlet, sorting facility, and detention basin. The difference in design between Amupin and other projects lies in the multifunctionality. It enhances the tunnel's added value. It can not only perform a hydraulic discharge during floods, but also serve as a conduit for dredge pipes and gravel trucks during the normal and drought periods. So we set up the sorting facility and detention basin to manage the dredge silt. Coarse particles are sorted and transported to reuse, and while fine particles are stacked and await for hydraulic flushing. In regards to detention basin, we conducted hydraulic model tests and numerical modeling to deal with the shortcomings of the traditional design. And the three groove plan we developed yields a better results in sediment releasing. To provide a sealed storage space, the three radio control gate require a width of 80 meters, making them the widest in Taiwan. And after the Amupin desilting tunnel was completed, it can discharge 0.64 million cubic meters of sediments per year. And this value also equals to 53,000 gravel trucks. And in the slide, is the initial operation benefits of Amupin desilting tunnels. During the Typhoon Himalayan in September last year. And for this operation, a total of 0.2 million cubic meters of sediments was released. And the operating condition was at the outlet is below. So at the end, I will conclude my speech by summarizing in 4 points. First, yes, desilting tunnels offer a highly efficient and cost-effective means of reducing siltation. In the case of Zhengwen Reservoir, it reduced annual dredging costs by about 23 million USD. However, hydraulic desilting works better during flood events when turbidity currents occur. And secondly, the Zhengwen desilting tunnel face significant engineering challenge and demanding unique construction method, so it still remains difficult to replicate and surpass. Thirdly, the Amupin desilting tunnel was innovatively designed to integrate various desilting strategies, and it combined the important modern values such as environmental friendliness, carbon reduction, and source recycling. Lastly, given the increasing occurrence of extreme hydraulical events, the desilting tunnels will become more vital in sediments losing. So we firmly believe that in the future, they will play a crucial roles in reservoir sustainability. And thank you for your attention. Thank you.
Economics and public administration. So I am trying to. I was really introduced. I mean, overwhelmed by the work that were. Yeah, where is? Hello. Okay. Oh, okay. Yeah, so the transdisciplinary approach and all those things, it was really interesting to hear from the previous session also. So maybe there might be few instances where I will be also sharing those experiences. So the topic of my presentation is about the applications of UAV and different frontier technologies for disaster risk reduction. So talking about Nepal, I mean, it's a beautiful country, but it has so many disasters, and we are always like we face a lot of challenges. And every year, if you talk about the landslides only, it's like more than 113 deaths we have every year if you take the average data from the past 50 years. So it's an alarming issue, and also the patterns of climate change are also visible in the form of intense weather storms that is also contributing towards the number of floods and so on. So it's a difficult situation, but uh, what I feel is necessity. I mean, necessity is the mother of invention. That's why I think these kind of problems are there. That's why we need to work. That's why we are civil engineers, and that's why we are problem solvers. So that is the mul mantra that I always take. So I would like to proceed with my presentation. I would like to start with this drones. We call it drones. Somebody say, "Oh, this you are using drone. You are invading us. You are interfering us." And somebody say, "Oh, drone. Wow, it gives a very high resolution output," or something like that. So yeah, the thing is the same, but we have mixed perceptions. We get either good perceptions or it might be bad as well. But what it matters is it all depends on the purpose that how we use. If we use this for the rational purpose for the contribution of the society, then obviously it's going to be the for the good use. And if we, I mean, invade or if we use for the other rational purposes, then obviously it's not just a tool, but it can be a dangerous weapon as well. So it's all about having the rational use. And uh, there are so many names for drones. somebody call it UAV, unmanned aerial vehicle, UAS, RPAS, RPV. So it can be the different name, but all it possesses all, I mean, the guiding principle you can see over here. So these are the three guiding principles. The first of all, it needs to fly. It needs to fly. Then it has got inbuilt camera and GPS. That keeps in. I mean, it has got camera that clicks high resolution for photos, and then it is guided and it is controlled. I mean, it has GPS. So because of which we can geotag any photos and we can join all those photos by the principle of photogrammetry. So this is the basic component of drone. And why drone, especially, I mean, considering the disaster situation, as I already told, it is very difficult, especially in the countries like us, in the Himalayan regions. There are so many problems, and it is very, the conventional method sometimes does not find to be very effective. So on that note, we might have to look for some innovative or some new technologies, so which I'll be talking about. And the reason why I'm presenting today is the importances of drone. I mean, whenever there's a disaster, you can simply go and deploy the drones. For instance, if it's raining heavily, like if it rains 300, 400 millimeter or 140 millimeters in a single day, during that period, it's all cloudy and you can't invade through, I mean, you can't have a good sight, good view from the satellite images. And we also don't get very, I mean, currently, near real time images is also not available freely of high resolution. So what can be a very good solution is it's the drone. We can simply use it. And if you, depending upon the height and the camera resolution, you can set the ground sight distance and you can have very high resolution. And the another important part is we fly the drones below the clouds. That's why we don't have any issues of cloud cover. But in the satellite images, we have issues of cloud cover. And another one is it is also cost effective. It does not require a lot of resources. I would like to now give an example that I have kept here. You can see in the same instant, our team from Nepal Flying Labs, and this is from the Tanzania Flying Labs. So you can see on the left, it is all covered by the cloud, but when you can have drones and when you can deploy the drones, then you can get such images. So the best example of using drone is this. And talking about the resolution, this is the normal image that if you take the sentinel images of 10-meter resolution, and then if you use drones, you can see it's the same place, but a bit later time, but the same place. You can see very high resolution and you can distinguish objects on that. And you can simply look at this image as well. If you look at the terrains, if we go for the satellite digital elevation models and very high, coarse resolution, then sometimes the terrain is also underrepresentative. On that note, drone can give you a very high resolution data sets, which can help you to get a very good contours so that you can have quantity estimates and preparations of all those quantifications. And there are some areas, for instance, if you want to go and have a look at the landslides, I don't think it's wise to walk on those landslides because there are some areas which is very difficult to get access. So on those inaccessible areas, the use of drones is very relevant as you can simply use the remote control and then fly your drones over those areas. And these days, it has also been a powerful tool for storytelling. Just using the, brochures or pamphlets and walking in the streets rather than having a bird eye view and then showing the mass and giving praises to the government or something like that. So it is also being used for those cases. I don't want to go much here, in detail here. And it's about, talking about the viewing angle. As I said, you get a very good bird eye view and you can look over the area and also plan for any kind of interventions that you would like to do. And this is an interesting, oh, yeah. So this is a recently completed project which I did. You can see this is a very, it's a UNESCO World Heritage listed project. It's the Changunarayan Temple in Bhaktapur district of Nepal. So with the help of drones, we developed the 3D models. So drones can also be used for the development of such kind of models with very high details and high resolution. And it's not just about the temples. We can develop 3D models for landslides and so on. And talking about when we fly those drones, then what we get is these sort of things. First of all, we get access to the ortho mosaic, that is you can stitch all those different images that you click in different instant. And by using the GPS and special reference, you can connect all those images and create a large base map, or we call it auto mosaic. And another one is digital surface model based on the reflections that is through the web. So you get the estimation of height as well. So you can also develop digital surface model. And if you use different sensors, for instance, you can use multispectral sensors and so on that can be used to detect vegetations. And if you use thermal sensors, for instance, whenever there is flooding or whenever there is earthquake, and if people are even trapped inside the buildings, then the thermal sensors drone can go fly in and then they can detect, okay, there's somebody inside these things. So these things are really important. And we had some of the used cases in the Gorkha earthquake 2015 as well. So these are some of the outputs from the UAV processing. Now, here comes the question, what next? We have drones, we have fancy drones, we click the photos, we developed all those ortho photos and then digital elevation models. Then what next? So how can we apply it in different phases of disasters and also towards the civil engineering? So basically for the we do have four cycles. It's prevention, mitigation, first phase. Second is preparedness, third is response, and the fourth one is recovery. So drones have applications in all these things. So I would like to quickly go on to some of the applications. Since my presentation is all about sharing the case studies, so there might be a number of projects. Uh, I hope you will not get bored. So the images that we collect from the drones, I mean, when we prepare the ortho mosaic, then these days we have very interesting AI tools. So simply you can upload that images and then you can train your models and then you can digitize all those buildings. You can see on the image on the right. So the high resolution images will give you a very good sight of all those houses, buildings, I'm sorry, roads and other utilities. So you can simply digitize them. And you can see here, this we also use these drone images. Okay, we also use these drone images for the digitization of the roads. So it was later used for the metric addressing system. So with the help of the images of the drones, you can simply prepare the the good inventory of the roads and buildings, which can be used for the house numbering or street addressing or anything other purposes. Besides, okay, this is one of the application of high resolution digital elevation model. So we flew the drones in landslide prone areas, and then with the help of like we generally we get free DEM of like 30 meters resolution, course resolution, but we had this resolution of like 30 centimeter. So with this drone, I mean with this digital elevation model, we applied this. We used factors like rainfall, geology, slope, aspect, curvatures, 10 or more factors to develop this landslide susceptibility map. The areas which you can see red are the areas which has higher probability of landslides, whereas the yellow has the moderate and the green has the least probability of landslide. So the outputs of these products can be used for the susceptibility and risk mapping. You can see these are some of the digital elevation models that we derived from the drones. Okay. Besides, I would like to share an experience of Gorkha earthquake 2015. After the Gorkha earthquake 2015, it was really difficult to find the open areas so that we can, have people for the emergency response or something like that. So on that note, with the help of drones, we also mapped like 83 open spaces in Kathmandu Valley. So everything, the details, the area of the open spaces, what are the amenities required, everything were then prepared and then it was integrated into the national this BIPAD portal, that is the National Digital Information Management System. So this was also done with the help of the drones. And also with these drones, we also looked for the evacuation route modeling. What areas could be the, shortest distance to reach to the safe places and so on. So this kind of applications can be made with the help of available high resolution data sets. And there's an interesting work that we did. One of my colleague, you can see the helicopter. We didn't fly the drone because it was really difficult. we were about to map a glacier, and in that area, it was very difficult to operate the drone. So what we did is we mounted the drone camera under the helicopter, and then we just had a round over the area, and then we developed the digital elevation model. So on that note, we also our colleague worked towards the a project regarding the lowering glacial lake lowering. So this is also getting very popular in having very high quality data sets and also applying for this kind of risk mitigation, risk reduction works. So this is what we can do before disasters. As I would like to summarize, it's about doing risk assessments, identifying areas, doing temporal analysis, and then preparing the updated base maps and many more. So this is what we can do with the help of drones, and that will contribute towards the risk reduction. And there are some more interesting examples which I would like to share upon. It's about the application of disaster risk management during the disaster. So you can see this is a place in Gorkha, Manbu, where we had a massive debris flow, and you can see the houses nearby. So these houses were very, I mean, they were susceptible to those debris flow. Many of them had to like run during the night because of this event. So after this Manbu debris flow, what we did, our team went there, prepared a flight plan, and then conducted the survey, and then we highlighted all those elementatrix. You can see the buildings, yellow buildings, how many buildings are there, and then what could be the vicinity, how far is that building, such kind of analysis. And also we also tried to examine what were the reason for this kind of debris flow. And what we realized was there was some interventions that were carried out in the top that blocked the area, that the drainage, the water didn't pass away. So it collected for a time and then it burst. So that resulted into this kind of event. So these things were also like identified or that were aided by this drone survey. And you can see after that we obtained this orthophoto and digital elevations model. And then we also carried out some geological mapping and also the ERT survey so that we could scan to what extent the water is available and to what extent there is the good rock. So we carried out those kind of surveys, and then we started to explore the potential solutions for those reasons. So in this way, drones and frontier technologies, other technologies could be used to assess and anticipate the risk. You can see, and after that model, after that digital elevation model, we applied FLOR to see the possible navigation or the propagation route of those debris. So you can apply other different models like AvaFlow and other models. So yeah, and another one, I would like to be quick then. So another one is the field assessment that we did in Melamchi debris flow. This was a massive event, a cascading event that we encountered. So you can see these are the houses. So it used to be a very small river. I can show you the image. Okay, you can see how it has been eroding. Okay, so this was the initial stage before that event happened. You can see very small river, but after that Melamchi debris event, you can see this is the images that we captured from the drones. So you can see a massive change and the massive deposition of all those debris in this area. And it was intense. It was really like our team, including me, got deployed just day after this event. And we had like a deposition up to perhaps like 6 meters or more. So it was massive. The two or third floor of the houses were all buried up. So that was the scenario. So our team went there. You can see a boulder of like 3.72 meter size. That big boulder was also there in different sites. And we also assessed how many buildings were lost and how many roads were damaged. So we assessed this. So there's a small ArcGIS story map that we prepared for this area. I hope it will run. So maybe I won't go more here. Okay, so you can see here, the red one is the flooding area, and the blue lines are the previous flow lines, and you can see the encroachment area by the flood. So we just computed all those, and it was very quick. Right after the event, we were able to do it within 2 or 3 days. Had we like waited for the satellite images, it would have taken a lot of time. So in that way also, drone can be quickly deployed. You can see we did some GIS calculations, and we did environment. We calculated this, and this is a very interesting example. You can see, so in the hilly terrains like Nepal, and especially in this region, there's a house. Whenever there's a blockage, this is the road that you have to go through. So it's like 4, 5, 6 hours you have to travel through this road. Whenever there's blockage in the road, you get completely detached. You don't get medicines, you don't get any kind of other informations, and so on. By the way, this project is for a piloting of the drones for the medical purposes. What we did is, instead of flying for 5, 6 hours, we took the sputum samples for the tuberculosis test. We collected the samples from that area. We flew the drones, and in 5 to 6 minutes, we kept it down to the district hospital. So in that way, we were able to escape this long route. And also, especially in the areas like ours, in the hilly terrains, drones can be a very savior. It can quickly deploy and send some medicines and so on, everything. So it's a very good example. So this is the project that we did. Uh, yeah, during the disaster, these are the things that we can do with the help of drones. Talking about this, after the disasters, what I have already shown, we can, with the help of the contour and the digital fine resolution data sets, we can design all those mitigation measures and so on. So also for the post-disaster need assessment, we can prepare a comprehensive report on different sectors, and with the availability of these flow patterns, we can design like what is needed. So as per our assessment, we found that we needed some drainage canals to be designed, and also some mitigation measures, some nature-based solutions that could be implemented in those areas. So in this way, with the help of drones, uh, we help for the recovery from disasters. We computed the quantity, we prepared the BOQs and so on. So yeah, I would like to now summarize. There are challenges. There are many challenges because it's not easily available. You need very good technical you need hardware for that. That is not available everywhere. There are challenges. You need a very skilled person to operate this, and you need to comply with all the government standards, because during the emergency, it's not just the drone, it's the helicopters and everything that roams around. So if you're gonna have a fight with the helicopter, that's not gonna be okay. So you need to be very cautious while you use the drones and so on. So we need to have the rational use. There are challenges on different aspects, so we need to handle them. And then I think the technology can be both. It has good aspects also, it has bad aspects also, but all it depends on how rationally we use. So I would like to focus onto this, and I would like to summarize by saying this. So it's not just about the technology, it's about how we make the use of this technology, because there are so many robust things that are available. But as long as if you can make the best use from those technologies, then that won't be worthy enough. So this is what I have in my final statement, and is not changing. So I would like to end my presentation here. Thank you so much. Uh, it had the thank you remarks and my email address. So I think that's I can share it. So I would like to now move on to the third presentation. The third presentation is about the assessment of climate change impacts on the water resources of the Laoag River Basin in Ilocos Norte, Philippines, using the SWAT model. So we have a KIC FLC Secretary, Ms. Maria, for this. So I would like to hand over my mic.
Okay, good afternoon, ladies and gentlemen. Again, I am Engineer Maria K.S. Eco, Maria for short, the female representative of PICE. Today, I will be presenting to you. Today, I will be presenting to you the assessment of climate change impacts on the water resources of the Laoag River Basin in Ilocos Norte, Philippines, using the SWAT model or the Soil and Water Resources Assessment Tool. I'm sorry. All are I'm reading Chinese here in my laptop and I was disturbed. Anyway, let me continue. Well, the objectives of my presentation is to check the capability of the SWAT model to simulate the Laoag River Basin, to check climate change effect on the hydrology of the river, and that would encourage policymakers and water managers to address the potential impacts of climate change to ensure sustainability of water resources in the river. So just a review, there are three sources of water, right? The groundwater, rainwater, and surface water. So I will be focusing on the river because as we all know, okay, as we all know, um, according to the Smart Water magazine, the river has an environmental and social rule, supplying fresh water, regulating water flow and quality, protecting from national hazards, and enabling. Ayun talaga. I'm good. I'm good. I'm sorry. Okay. Let me start over. Mr. Makbul, can I can I have another 20 minutes? Okay. Today I will be presenting to you the assessment of climate change impact on the water resources of the Laoag River Basin in Ilocos Norte, Philippines using the SWAT model. I'm emphasizing Ilocos Norte, Philippines because that's the province of our Philippine President, Ferdinand Marcos. The objective of my presentation is to check the capability and if it is able to simulate the hydrologic processes of the Laoag River Basin to check the climate change effect on the hydrology of the river and to encourage policymakers and water managers to address the potential impacts of climate change to ensure sustainability of water resources in the river. So there are three kinds of water sources: the groundwater, the rainwater, and the surface water. So I will be focusing on the river. So according to Smart Water Magazine, the river basins have an important environmental and social rules, supplying fresh water, regulating water flow and quality, protecting from national hazards, and enabling the conservation of biodiversity. So according to the UN, surface water bodies such as lakes, rivers, reservoirs are undergoing rapid global changes, with 1 in 5 river basins showing has high fluctuations in surface water levels. It's okay. I will just make it faster, ma'am. Thank you. The goal number 6 of the SDGs, ensure access to water and sanitation for all, emphasizes that access to safe water, sanitation, and hygiene is the most basic human need for health and well-being. However, the demand for water has outpaced population growth. Water scarcity becomes the byproduct of climate change, and water availability is becoming less predictable in many places. So let's take, for instance, the 17 ASEC member economies. Number one is Australia, that is now experiencing the water resource, the impact of climate change underwater resource. Bangladesh is experiencing floods. India's rivers are heating up due to climate change and may rise up to 7 degrees Celsius in summer by 2070 to 2100s. In Indonesia, they are now acting to protect the sinking cities from climate change. And the true cause of the climate crisis is being determined in Japan now. And even in South Korea, they are not exempted from this crisis, including rising temperatures, more extreme weather events, rising sea levels, and changes in agricultural yields. In Mongolia, they have this project that will benefit 1 million vulnerable people in a nation where climate change is threatening natural resources and fragile ecosystem. And in Myanmar, they have this study about flooding risks in the Lancong Mekong River Basin under global change. And in Nepal, they need to build resilience for the two major climate disasters in a single year, as per this news. And in New Zealand, they are now being affected of climate change through their fresh water. And I know everybody is familiar with this, the July and 2022 uh, flood that has devastated Pakistan. And in our country, the Philippines, it believes that it will lose 6% annually by its GDP by 2100s. And in Russia, roughly the land cover of Russia is covered by 65% permafrost. So just imagine if this permafrost will be melted, what will happen to Russia? And as changing climate could drain Taiwan's high-tech wealth, and even in America, um, is experiencing the impact of climate change. But sad to say, flood victims is still unaware of global climate crisis in Sri Lanka because the politician who came into power by promising to bring the culprits of deforestation before courts also engaged in deforestation. The forest officers remain silent. The people with power destroy forests using their power. Even certain media do not telecast news related to such deforestation incidents. And last but not the least, in Vietnam, the Mekong Delta is at risk, and it will eventually drown if this change issues will not be addressed. Indeed, climate change is real. As per goal number 13, there is no country that is not experiencing the drastic effects of climate change. The goal number 6 of the SDGs is located at the center, meaning failure to meet water sustainability, all other goals will fail. So there is a need to promote awareness on the issue to governments worldwide to come up solutions in increasing water efficiency and improve water management. And this can be done to help our policymakers, like Congressman Momo earlier. He has mentioned some of his projects. And policymakers will play a great role if we engineers, civil engineers, will provide them technical output to understand the present and future condition of our water resources. Besides, as per my reading, the United Nations is currently looking for world leaders in addressing these worldwide problems about climate change, water scarcity, and security. And in order to take part in this global issue, of the effects of climate change, it must start within us. As for me, I studied the current condition of the water resources of the Laoag River Basin and assess the climate change impact and assess the impact of the projected climate change and the hydrology of the study area. This technical output will provide sustainable management of water resources at basin level to our policymakers so that they will better understand the climate change effect, and it will provide a recommendation that can serve as a basis for developing policy intervention and sound management plans and programs towards sustainable development. Okay. The area where I stand is the study area. It is located at the northern part of the country. The Laoag River Basin has a total area of 1,351.88 square kilometer, occupying 39.2 of the percent of the total area of the province of Ilocos Norte. The existing land use is primarily agriculture in flatlands and forest reserve or reforestation at hilly and mountainous areas. Urban areas extend down to the Laoag City as the capital of the province and at the population of various municipalities. As for me, as a researcher, I'm not capable enough to conduct site inspection to project the future condition of this river basin. What I am only capable of is to have a photo opportunity like this and stand at the river bank. Thankfully, the instrument that I've used, the instrument that I've used it can assess the impacts of climate change on the water resources of that river basin by creating a model. The soil and water assessment tool is a semi-distributed hydrological model intended for water quality and quantity, predicting future scenarios, and that will be my focus, and managing water resources. Um, to sum up the operational framework of this study, the model was developed and parameterized using readily available data from which include IPSAR DEM and 2020 land cover obtained from NAMRIA, rainfall data, daily rainfall data from PAG-ASA, soils data from Bureau of and Water Management, and the model was calibrated using the stream flow data from the PWH where I work. So the model shows that it was able to capture the model, the hydrologic processes of the Laoag River Basin through Nash-Root clip efficiency with 0.331 NSE for calibration and 0.23 for validation. I will explain later why that is the value. Anyway, the value I used for the stream flow data for DPWH is for the period 2005 to 2016. Um, furthermore, furthermore, the model was calibrated or furthermore the model was simulated using the RCP 8.5 projected seasonal precipitation changes that will likely decrease by 10.1% in its precipitation and temperature by 1.6 degrees Celsius in 2050. So this is the water balance that was obtained from the SWAT model. It presented here the present and the 2050 water balance of the Laoag River Basin. Results of the projected annual water balance from the projected weather conditions projected by RCP 8.5 shows in this slide. And the annual rainfall amount will likely decrease by 7.27%, which will result in decreases of evapotranspiration by 2.7, surface runoff by 11.59, groundwater recharge by 10.19, and water yield by 11.10%. So what will happen if this water yield will decrease? So there will be water scarcity, ecosystem disruption, drought, impact on agriculture, economic consequences, human health, infrastructure strain, environmental degradation, and of course, social and political issues. If there is water scarcity, so what's next? What will happen? Water scarcity brings drought, and drought brings overpumping of groundwater. This occurs when more water is withdrawn than naturally replenished, causing a drop in the water table. Subsurface cavities created by karstification weaken the subsurface structure sinkhole formation form when the overlying surface layer collapses into the underground voids. These depressions can accumulate water during heavy rainfall or flooding events that will cause localized flooding. The extent of flooding depends on factors like sinkhole size, depth, and proximity to water resources. And sustainable um, groundwater management, monitoring levels, and proper land use planning can help to mitigate this problem. So that's the reason why we are struggling with water scarcity, and yet we are struggling with flooding. So to better appreciate the water balance, such as runoff, I will show to you the difference or the changes from present to 2050 as per projection. So there are changes in the land cover. This is for recharge. And in conclusions, the development and calibration of the SWAT model has been useful by studying the hydrologic processes of the Laoag River Basin, and it's capable and able to assess the impact of climate change and the hydrologic processes of the study area. And climate change adaptation and formulation of policies should be considered by infrastructure implementing agencies and policymakers by using the result of this study. So for the adaptation and policy recommendations, I have enlisted here the problem and the problems and the responsible agencies for each problem. Number one is lack of water conservation. This is to practice conservation by implementing policies that promote efficient water use, and who are guilty of this. To have restriction on water usage for non-essential purposes such as watering lawns, or washing cars instead of using those already used water. The responsible agency for this are the Department of Environment and Natural Resources, or DENR, the Ilocos Norte Water District, and stakeholders. For number two, no comprehensive management plan. This is to ensure that available water resources are used efficiently and sustainably. To consider the projected decrease in water resources due to climate change, and should include measures to ensure the equitable distribution of water resources. And again, the responsible agencies for this is the ANR and the Water District. And number three, water scarcity. To explore alternative water sources given the projected decrease in water sources, and to develop rainwater harvesting system, the use of treated wastewater for non-potable, and the exploration of groundwater resources. And the development of alternative water resources can be done by the ENR, the Department of Agriculture, the National Irrigation Administration, the Water District, water managers, and stakeholders. For number four, deforestation and soil erosion. To have an effective measure for increasing the water holding capacity of the watershed, to increase the forest cover in the watershed, and to help increase the water holding capacity and to improve the overall ecological health of the watershed. And this can be done by our Department of Environment and Natural Resources. Number five, lack of coordination among stakeholders. This is to better understand the impacts of climate change and to consider recommendations such as these studies about climate change, and this can be tackled for effective and efficient policymakers by our government agencies and stakeholders. And for number six, lack of information and education. Our students must be included here so that we could raise awareness and educate the public on the impacts of climate change and water resources, because there's no use of having such if it will just stay within us. We need to transfer it to the public, and this is to conduct information campaigns to inform the public on the importance of water conservation and sustainable water use practices, and to ensure that individuals take responsibility for their water usage and adopt practices that promote water conservation. And this can be done by our government agencies, the academy, and the stakeholders. And for number seven, just an additional lack of instrument. This is to recommend DPWH, my office, about acquiring a telemetered instrument such as the stream flow gauge with automatic weather station to have an efficient instrument for data collection. Because as I told you earlier, the data I have used for the calibration is for the period 2005 to 2016. So from 2017 up to now, they are still collecting those data because of the numerous gauging stations. So hopefully, this study or this presentation could help not only the Philippines but to every one of us. So, in closing, my today's presentation was adapted from my master's thesis titled "The Assessment of Climate Change Impact and the Water Resources of the Laoag River Basin in the Ilocos Norte." So, if there's anyone interested about my topic, because not every details are discussed here, you can contact me or my thesis advisor, Dr. Nathaniel R. Alibuyog. Thank you very much, and to God be the glory.
Thank you, my Jason. So I would like to hand over this stage to Dr. Jason.
Okay, thank you very much. My name is Jisoo Kim, and I'm really happy to see you here. And I'm from the University of Seoul and from Korea, and I am the Future Leaders Committee from the KSCE. And today I'm going to talk about the overview of the 3D concrete printing technology in construction and building industry. But I think some of you already have more and the better the experience or in have deeper the expertise in the 3D concrete printing. But nevertheless, anyway, I would like to introduce and provide some comprehensive overview of the 3D concrete printing in our field and also introduce the ongoing research from my side. And in the construction industry, the 3D concrete printing technology is currently a subject of active research field. And therefore, the many number of the studies and the researches have been conducted in the wide range of the area from the material development, especially for the printable material using based on the cement-based material and to the customization research. So for example, as you can see this figure, some research group or the industry already printed some castle and also the building and also the bridge. But in the civil engineering, we usually focused on the infrastructure. So I would like to introduce some examples of the the 3D printed bridge a few minutes later. And in general, the utilization of the 3D concrete printing can be categorized into two approaches. And the first one is to using the 3D concrete printing as the formwork. So for example, so it means that the 3D concrete printing does not use as the directly the structure element, but only for the formwork. So, for example, let's think about the typical slab, one of the structural elements. It has normally the flat shape, but when we conducted the topology optimization of the slab to change the shape of the slab, then we can obtain this kind of the optimized slab, the shape of the slab. But it is not easy and it is quite difficult to construct this kind of the slab because there are a lot of the irregular and the curved shape, the segments in the slab. And by eliminating some amount of the material in the slab, we can, it is anyway, using the conventional method, it is not easy to build up. But using the 3D concrete printing technology, we can generate this kind of the optimized shape, the slab with the optimized shape. So for example, we can print it each segment with the irregular and curved and very different and diverse the shapes. and then place in the certain the place, and then just pouring the cement surrounding the each segment and make the slab like this. Or in other research group, they use the 3D printing technique as the permanent formwork. So for example, they only printing the outside of the structure, which has the complex shape. But and then they just put the reinforcement or the reinforced bar into the printed element, and also the fill the cement based material inside, and then they use the printed one as the permanent formwork, and after the hardening they the printed the element is not the formwork anymore but used as the part of the structural member. And the second approach to utilize the 3D concrete printing is using that as the structure member directly. So when you see here, this is one of the famous the research conducted from the Eindhoven University of the Technology, and they printed the rear the 3D printed bridge for the bicycle. So when you see here, they designed the specific the cross section and they printed all the segments, which is the more than the 5 or 6 segments, and they assembled and they combined each segment using the post tensioning. So they found it is okay, and it is just like they just using this bridge in rear in the actual one. So there's some very famous example. And the second one, another research group, they conducted the topology optimization for the pre-stress girder, and they designed the simple and very slender the shape of the girder, and they conducted and simulated and they simulated and evaluated the structural integrity or the performance of the designed girder using the finite element analysis. And then they compare the result from the simulation with the experimental data. And they mention the several key benefits when they using the 3D concrete printing. And one is we do not need the molding or the demolding process as in concrete casting. And second, we can save a lot of the material by reducing the material significantly. And third, they found the possibility of the autonomous the robotic manufacturing from the design the girder to an a prediction of their performance and to the construction of the girder using the 3D printer. So this is last the kind of the last slide for the examples of the printed grid. And I really like this one because it looks fancy for me. And some the recently in the 2023, so some uh, group printed the arch shaped grid. So as you can see here, maybe you might think that maybe the 3D concrete printing technology have been almost complete and there's no more studies. You can feel like that, but actually there still have a lot of the challenge because we have to develop the new material for the construction, and it is not the same as the conventional and the normal concrete because we have to print the material. So we have to check the several the conditions, for example, the rheological, the characteristics of the material, and so on. And also nowadays we have to think about the eco-friendly and also the economical, and also how we can reduce the emission of the CO2, something like that. So we have to develop the material, at least the cement-based material, or the formed concrete, or the lightweight the aggregate using the lightweight aggregate. So there's a lot of the research field in the 3D concrete printing, and moreover, as you can see here, the most of the printed the structure is for the bicycle or the person, not the car or truck, something like that. So we have to improve the technology of the 3D printing to enhance the performance uh, by combining some other the conventional one. So this is I'm still on the way to get the solution for to and to solve that kind of the problem. But I would like to introduce today about my very basic research output today. So actually, this is the what I did when I was the postdoctoral researcher, and I and my colleague printed the three pre-printed wall elements. And as you see here, we designed the seven different types of the words, word elements, and we want to check which one is the best or optimum shape for the thermal performance and the structural integrity and also the topology efficient. And we before we printing all type of the word element, we would like to use the simulation tools to find out and suggest the candidate for the optimum designs. So we conducted the thermal analysis and the evaluate the what which the structure could be the best in the the structure behavior, and which one is the best for compared to the amount of the material. And we found the two or three the candidate, and we just printed the rear side. But actually, it is not that big. But anyway, it has the 1 meter the length and the 30 centimeter, and it has the 45 height. But it should be mentioned that our word element has the inner word and the out is has the outer word and the inner word, but each word is composed of the two filaments. And we during the compression test using the printed word, we found out the interesting the failure modes. The first one is the war failed and destruct at the connection point and connection region between the internal and the external world. And second, we found that the outer line, the second filament in the outer were for off or spooling from the second filament, which means the you can see there the two filaments debonding each other when they got the compression strength. So we concluded that the adhesion or the bonding performance between the filaments could be a major impact on the performance of the 3D printed structure rather than the bonding between the elements. Someone just worry about the bonding between the layer because the 3D printing structure mainly constructed layered by layer, but it is not that much big issue compared with the issue between the filaments. So we focus on that problem, and we conducted the secondly uh, focus on the interfilament the behavior. So we designed and we printed a very small size sample, which is the prism with the 4 centimeter, and 16 centimeter, just like the Fletcher, the test prism. And but we designed the patterns, the three different patterns, and pattern A and B is the mainly the longitudinal directional the filament for filaments, but pattern C has two different filaments combined. So when you see here, pattern A has the snake-like shape, so we can expect kind of the confinement effect each the filament. But in the pattern B, it is just the printed the filament in order from the left to right, or the right to left. So we just want to compare what happens in the region between the filaments according to the different pattern. So and to find it is not easy to measure the bonding the properties of the structure. We decide to take the microcity image to obtain the pores inside the structure, and we just say if there's a lot of pore, it means there should be the very less the bonding each other. So we apply the microcity analysis tool, and we just take the microcity using the whole the printed specimen, and when we see here. Uh, we can get the pore distribution in three-dimensional. So we can just taking the every the cross section the microcity image, we can make the 3D virtual specimen which has the same shape with same uh, microstructure and same shape with the actual specimen. And using that these the virtual specimen, we investigated the pore distribution inside the specimen. And as you can see here, the dark gray means the pore, and the light gray is the is a solid phase. And when you see here, it is clearly shown that in uh, the A and B, we can clearly see the dark gray is in the oh, dark gray is in the region between the filaments. I will call the interfilament, and also you can see that you clearly see the dark gray concentrated in the interfilament region. So it can, but in here, when we see here, there's no any the concentrated pores inside the filament. It means the each layer bonded very perfectly, like the casted one. So we found using the microcity image, and but when we see the pattern B, which is the pattern in the longitudinal but in order, so we couldn't expect any confinement effect on this pattern B. But anyway, we can see some of the large, the dark gray regions between the second and third filaments. So there is not the completely uh, bond each other. So we guess it should be very weak performance on the mechanical properties. And the pattern C, we can see very not kind of the uniform, but anyway, there's some of the very different distribution characteristics compared to other patterns. And based on this imaging analysis, we conduct a quantitative analysis using the porosity distribution and porosity profile along each the direction. And when we compare the pore distribution, and we can clearly see the three distinguished peaks in along the perpendicular direction. So it means we can see, and there should be a lot of the pores between the filaments. So we have to carefully resolve this the behavior when we printed the structure. And then when in the pattern C, there's not that much clear the peak in the middle. It is because we choose the two different pattern combined. So the pore seems more the uniform and the isotropic characteristic. It is becomes the isotropic behavior. And from here, this is almost the last the slide. When we compare the microstructure characteristics with the mechanical properties, we can conclude that the pattern A is one of the optimum and the best performance among others. And as you can see here in the pattern C, it has the lowest fracture the strength. It is because it includes and it involves the pedular directional the pattern with the loading, the fracture loading the direction. But in the compressive strength, the pattern B has the lowest one. It is because we couldn't expect any the confinement effect, and by adding the gravity and additional the layer during printing, the reason between the second and third filaments is detected as much as possible. So from here, we for the best and optimal pattern printing, we have to think about which pattern could be the best, and we have to compare. We have to design the every pattern, basically considering the whole the phenomena on this kind of the behavior. And this is the conclusions so further better understanding of the 3D concrete printing behavior, the multi-scale analysis from the material and element to the element or the material to the structure must be carefully investigated for better investigated. And I read the news that this is a bird's eye view of the 3D concrete printing booths in Paris for the 2024 Olympic Games. So I hope we can enjoy the Olympic in the next year with the 3D concrete printing booths. Okay, so thank you. This is all from my side. Thank you very much.
I get Maria, Suraj.